video, I'll be teaching you how to interpret the meaning of an electrocardiogram, or ECG. So, an electrocardiogram is a graph plotted with time in relation to electrical activity. So I'll just draw a sample electrocardiogram. There's something like this, and then you have this sort of thing, and then you have another bump typically here. So this is known as an electrocardiogram. And every single repeating pattern in an electrocardiogram is a representation of one full cardiac cycle. Let's just say that this is one full cardiac cycle. And then we can go ahead and label it. So the first thing that we want to label is the P wave. I'm going to see if I can somehow change type of. Okay, that's not what I want. Okay, but let's first go ahead and label the P wave. Okay, so this eraser's here. Alright, so we have a P wave here. And the P wave is caused by an atrial systole. So the atria is contracting. Whereas a systole is caused by contraction and a diastole is caused by relaxation. So this is the P wave right here. This is the P wave, and it shows the amount of voltage given off by the sinoatrial node. So it shows voltage given off by the sinoatrial node, the SA node, which is essentially the pacemaker of the heart. Next, we can label the Q wave, which is right here. And there's going to be some kind of delay between the P wave and the Q wave. So the Q wave signals when the atrioventricular node, or the AV node, sends its impulse. Next we have the QRS complex, which is this, the QRS. Over here, QRS complex. And it's caused by a ventricular systole. So whenever we say the word systole, it means that the ventricles are going to be contracting as opposed to a diastole, as I mentioned before. So this is a ventricular systole. I'll just put in brackets that it's contracting. So basically, you have the Q wave. It signifies when the AV node sends its impulse, and the QRS complex is when this impulse sent from the, which is signified by the Q wave, spreads through the AV, well, it flows from the AV node and it spreads down through the conducting fibers and out to the Purkinje fibers within the ventricles. So we can mention here that it spreads down conducting fibers. And what else? It also moves out to the Purkinje fibers. Purkinje fibers. This has to do with the right and left bundle of His. The Purkinje fibers of the ventricle. So that's the QRS complex for you. And then there's also the final type of wave is the T wave. And this is caused by a ventricular diastole. So this is when the ventricles are relaxing. So this is a ventricular diastole. So the QRS complex is caused by a ventricular systole, the contracting of the ventricles. The T wave is caused by a ventricular diastole. This is when the ventricles are being relaxed. So in this phase, the atrioventricular node, or the AV node, is repolarizing. So when you repolarize something, you're essentially preparing it for another reaction. So in this case, it's preparing to send another impulse. So this is basically a pretty brief overview of how to interpret an electrocardiogram, which is graphing a single full cardiac cycle. So first we have the P wave. It's when the atria contract, and it shows the voltage given off by the sinoatrial node. Then we have the Q wave, which is when the AV node sends its initial impulse. Then we have the QRS complex, which is the ventricular systole, or the contraction of the ventricles. It spreads down through the conducting fibers, and it moves out to the Purkinje fibers, which are located within the ventricles. The Purkinje fibers. And then we have the T wave, which is the final part of the electrocardiogram, and this is the ventricular diastole. So this is when the ventricles are relaxing, and during the T wave we have the repolarization of the AV node, in which it prepares to send another impulse.